This is page 265. This is the guided practice for lesson 10.1. Some of this stuff has been pretty abstract and possibly pretty tricky. This is the point where you've probably had enough practice to where you can start to give it a try. I don't expect you to be able to complete this page in full, but I think you should give a real good effort on this page to try these problems without the video and then play the video when you're ready to check answers. So we're going to do a lot of pause and play on this page. All right, guided practice, numbers 1 and 2. The directions read, write each phrase as an algebraic expression. So we're given the problem in a phrase, and we're supposed to write it as a math problem. Algebraic expression means that we're going to have a variable and a constant and an operation. So the first one is 3 less than y. This is not 3 minus y, this is y minus 3. Because it says right here that 3 is less than y, which means it's a smaller number, and the smaller number goes last. It's going to be y minus 3. I know a lot of kids are going to get that backwards, and it is not okay to change the order when it comes to subtraction. Number 2 says the product of 2 and p. Product means to multiply, 2 times p. And we always want to put the constant first, so it's 2p. No x. If you put an x in here, it's wrong. All right, numbers 3 and 4 say write a phrase for each algebraic expression. So the phrase for y plus 12 could be either something like y plus 12 or y added to 12, or you could even go a little bit more complicated and write the sum. I like to use the word sum of y and 12. Number 4, p over 10. If you want to be simple, you could write p divided by 10. You could write the quotient of p and 10. I'm just going to go simple on this one. I'm going to do p divided by 10. Again, if you wanted to be a little bit more complicated, I'm going to do an or. I'm going to do 2 answers. Or another answer would be the quotient of p and 10. Both of those work. All right, number 5 reads, draw a bar model to represent the expression m divided by 4. Well, this one should actually be somewhat easy. I need to kind of go ahead and make a little space. Hopefully you're done with 1 through 4 because I got to erase those. Make a little bit of space for number 5. And so we're going to take m and divide it by 4. That means the whole thing has to be m. And it needs to get divided into 4 even chunks. And then the answer would be any one of these chunks where you have m is being divided into 4. So what's happening here is the whole thing is m. We're dividing into 4 chunks. And if you're like, well, that's 3 chunks. Well, just count them. It's 1, 2, 3, 4. And so then each of these answers, how much is this right here? This is not m. This is a fourth of m. And the way to write a fourth of m is m over 4. M divided by 4. All right, moving on. Again, I know those models are hard, but we'll get through it together. 6 and 7 go together. Number 6 reads, at 6 p.m. the temperature in Phoenix, Arizona T is the same as the temperature in Tucson. So let's make the first one over here be Phoenix. I know I need to read the rest of this, but I will in a minute. Let's make this one be Phoenix. And this one be Tucson. And they're the same right now. And that's why they both look like T. T stands for temperature. So right now they're both T. They're going to change though. So it says at 6 p.m. the temperature in Phoenix, Arizona T is the same as the temperature in Tucson, Arizona. By 9 p.m. the temperature in Phoenix has dropped 2 degrees, and in Tucson it has dropped 4 degrees. By 11 the temperature in Phoenix has dropped another 3 degrees. So 6 says represent each city's temperature at 11 p.m. with an algebraic expression and a bar model. All right, so what do? We go to Phoenix and we read carefully. What happened in Phoenix? Well, it dropped 2 degrees. And let's go ahead and let's do Phoenix. Phoenix has dropped 2 degrees. And then Phoenix has dropped another 3 degrees. Well, how many is that? It's 2 and it's 3. So we're going to sketch out 5. So somewhere along the way it said it dropped 2, so we could put minus 2 here. And then later it says it dropped 3. So pay attention to where the minus 2 is. The minus 2 is these 2 together, and the minus 3 is these 3 together. So the temperature was T, and then it dropped 2, and it dropped 3. That's not too hard. And then Tucson only dropped once. It dropped 4 degrees. That's right here. Tucson dropped 4 degrees. So we just sketch out 4 of these guys. 1, 2, 3, 4, minus 4. It didn't drop twice, it only dropped this once. So T minus 4. Are they the same temperature? Number 7 reads, are the expressions that represent the temperatures in the two cities equivalent? Just for answer. It's no. And there's different ways to justify your answer. You could say the models aren't the same. And how come the models aren't the same? Well, the models aren't the same because on Phoenix we took away 5 degrees and on Tucson we took away 4 degrees. So they're not the same. And the expressions aren't the same. But we could also say, the temperature dropped more in Phoenix. And that's true. The temperature dropped 5 degrees in Phoenix. I'm going to write that. The temperature dropped 5 degrees in Phoenix and 4 degrees in Tucson. And I'm kind of out of room, and I'm going to write in parentheses 4 degrees in Tucson. Talk about using all my space. I know that's a little bit messy, but let's just review. The temperatures aren't the same in Phoenix and Tucson because in Phoenix it started at T and then we took away 2 and 3, so that's a total of subtracting 5. And in Tucson we took away 4. If you subtract 5, it's not the same as subtracting 4. Awesome, let's move on to number 8. Number 8 reads, Noel bought some boxes of water for a picnic. Each box contained 24 bottles of water. If C is the number of boxes, write an expression to show how many bottles of water Noel bought. So what we're going to do here is we're going to recognize a couple of things. Each box contained 24 bottles of water. And so now the big question is how many boxes of water did she buy? And we don't know. You can read as carefully as you want, but we don't know because it says she bought some boxes of water, but we don't know how many. And it says if C is the number of boxes. So what does that mean about 24 and C? It means 24 times C. And here's why that should make sense. You get 24 bottles in each box, but you don't know how many boxes we buy. Well, that would be 24 times C, because if you bought 1 box, it would be 24 times 1. If you bought 2 boxes, it would be 24 times 2. If you bought 3 boxes, it would be 24 times 3. Notice what I keep saying. I keep saying 24 times. That's because this problem, this expression, should be 24 times C. That's all you have to do for number 8. It doesn't ask for anything else. You just had to write the expression, and you just had to notice that this was going to be multiplication. Alright, so number 9 reads, give an example of a real-world situation that could be represented by an algebraic expression. So this could be as simple as, let's say you babysit. You earned $15 for babysitting on Monday and some more money for babysitting. I needed to say Monday and I forgot it, so I need to go back and fix it. You earned $15 for babysitting Monday. I'm going to put on Monday to make more grammatical sense. You earned $15 for babysitting on Monday and some more money for babysitting on Tuesday. How much money did you earn on both, combined on both days? Well, this is an algebraic expression. Do you know why? Because to answer this question, we don't have all the information. The reason this is an algebraic expression is because you earned 15 on Monday plus some more money on Tuesday. And how much money is that? You don't know. In fact, I'm going to go ahead and delete that equal sign. It's 15 plus C. 15 for how much you earned on Monday, and C for you don't know how much you earned on Tuesday. So it's 15 plus C. The key to something like this is right here where it says algebraic expression, the key is you need to have some missing information. And my missing information was something like this. Some more money on Tuesday? Well, we don't know how much it was on Tuesday. But that's what makes it an algebraic expression. Because we don't know, we have to use a variable. All right, outstanding. Good job. You are done with page 265.